Hello, everybody. This is Shad here in another edition of New Year Workshops. Pretty excited to have actually one of the first indexing workshops with Sean from Subquery. So if you don't mind, I've taken it away and yeah, showing us how it's done.
Awesome. Thank you so much for that shot. And again, welcome everyone to the virtual workshop on data indexing here with Near and Subquery. Super excited to be here. You probably noticed we're recording as well. And great to see a number of people, some familiar names as well. So great to see that. So let's jump straight in, jumping to the next slide here on the agenda. The workshop is about 25 minutes long, where we're going to go through four main points you can see on screen. The first one, we'll talk a little bit about the problem that we're trying to solve, and then we'll see how Subquery approaches this solution. We'll jump into a quick demo as well, so if there are any programmers on the call, feel free to follow along as well. It will be a live demo, so fingers crossed that it works. I did test beforehand, so I'll see how that goes. And then we'll have Q&A at the end, some discussions as well. However, if you do have any questions, feel free to type them in the chat window as well. So let's jump straight to it. First of all, what are the challenges that developers are facing when building amazing dApps within the Near ecosystem, right? Well, what we've found is that developers are asking, where and how do I get blockchain data from to power all the apps that I'm creating? And you probably think, well, you just get it from the blockchain, right? But it can be quite tricky in terms of how we do that. So this is where Subquery comes in as an end-to-end Near ecosystem blockchain. We've also got a managed service as well, because once you download the code and you start grabbing data, you're running on your computer, right? Local host. Of course, you can host it, say, on Google Cloud, maybe AWS, but we've also got this managed services just for your convenience as well. And then the third piece on the right-hand side here is that we've got this decentralized marketplace. So what you can do is if you've got a project, we've got indexes in this marketplace that can help take your project, index it, get the data, and then basically sell the data to consumers, right? And even yourselves, you guys, people on the call can become indexers and basically generate some sort of or earn rewards from indexing data on the blockchain and making it available to those who want to make use of it or consume it. So that's what Subquery is. And a lot of people ask, well, why use Subquery? What are the advantages or the benefits? Well, there are a number of benefits. The first one, as mentioned, being open source. However, it's also quite easy to use because we do have this Dockerized container environment where you can actually get up and running within minutes. And hopefully we'll show you that in the demo very shortly. It's also very simple to use because there are literally 3 files that you have to modify in order to get a project up and running. And again, we'll take a deeper dive very shortly. It's also very customizable because you can specify the exact data that you need from the blockchain to power your application. And when you specify just the data you need, it actually becomes quite fast and lightweight. It's also feature rich. There's lots of things you can do with the Subquery SDK. Example was historical state querying. Another one is if you have an ABI, the smart contract address, an ABI file, you can actually give that to the project, and the project will go ahead and create all the functions for you from the ABI file. So it makes creating a project really fast. It's also real time. So you're actually indexing in real time as the blocks come through, and they're generated as well. So there's very little lag. And one of the main benefits actually is this multi-chain feature, where when you create a project, you say, what blockchain do I want to grab the data from? So of course, being in the Near ecosystem, you can grab data from Near, but what you can also do is actually specify data from other ecosystems as well, such as, say, other EVM chains, maybe Cosmos, Algorand, Polkadot, etc. And you can bring all this data in this one single project, effectively storing the data from different chains into one database. And what happens is that you can almost have what is termed this unified API, so to speak, making it nice and simple to get the data that you need. It's also very flexible, as mentioned earlier, where you can host in locally, manage service in the decentralized network. The EVM, Ethereum space and ecosystem is very large. So these are the benefits here of using Subquery. And on this next slide, the top here, we've got the EVM networks. And then, of course, Polkadot on the right-hand side here, Cosmos, Algorand, and of course, Near here. And we want to help grow the Near ecosystem as well, helping the developers get the data that they need. Okay, so that was a very quick overview. Let's now jump into the Near startup. And this QR code if you want. I'll put the link actually into the reference. It's basically a link to GitHub repository. Near folder, so this out, put it in the chat like so. And this is the starter project that we're going to use in our project, right? So as mentioned, if you are a coder, there are some prerequisites required, and you probably have number 1 and 2 already. Yes, you quickly will know if you're using Brew, download it from the website. The same with Docker as well. The last one here you may not have, because this is the actual Subquery command line interface, or CLI, and you can install this very easily with npm install -g for global at subquery/CLI, and I've got this in the chat as well, just for your reference. And once you've got all these 3, what we can do is start creating a project. Now, as mentioned, it is simple. There are only 3 steps involved, effectively modifying 3 files. Right. Number 1 is we want to define what we call the shape of the data we want to index. So what kind of data do we need? And we can specify this in what we call a schema file. Number 2, we then go ahead and look at the manifest file, and we configure the endpoints and the filters. Because once we know what data we want, we need to know where to get it from. And then the last step there, step number 3, we want to transform our data with the mappings file. And this is where a lot of the coding happens. We can transform, we can aggregate, do all sorts of things within the actual data itself to get it to a state to drive our, say, mobile app, for instance. All right, so that's a bit of the background there. So let's go ahead and take a look at this project overview. The goal is we're going to index in real time all price submissions from the priceoracle.near on Near mainnet. And again, a couple of references here, the Near Price Oracle example project, which I'll also put in the chat here. So this is the project that we'll be running. There we go. And there's a link to a quick start guide that I'll be along as well. I'll share this on the next screen. Okay, so let's go ahead and jump in. Let me go across to VS Code here. And again, I'll just give you a brief intro here to our documentation website here, academy.subquery.net. On the left-hand side, if I go to specific chain and then scroll down, you'll see we've got near. Click on near. And this is what we'll be working on. So I'll refer to this very frequently. But first of all, let me jump into VS Code. And again, if you do have VS Code up and running, you can try this out. Where what we'll do is we're going to run subql init. So this is the very first initialization command. Let me call near demo project. And it is, I'm going to, you can see a of NEM called near, and then I'll select the near network. I can nice or example here is what we're going to be building. But if you select this one here, it's basically the end state, the code, the answer, so to speak, right? But I won't choose that because I'll choose the starter project first and I'll build it. So let me try this. And then automatically on the right-hand side, you can see we've got the scaffold or the structure of the project all created for us. And this makes our job a lot easier as well. So back to our command line here, we need to provide an endpoint. If I just hit enter, the yellow default will be accepted. So let me just accept the default here. Just for demo purposes, I'll just select and agree, and then that's it. The very first thing after this is I want to cd into my folder, right? So near demo project. And as always, with every single project, you want to install the dependencies. So I can do this by going yarn install. This will take maybe 30 seconds, depending on your internet connection. While this is loading, let me just click on the schema file, because remember I said that this was step one, where we define what we want to index. So here we've got 3 entities, and we're indexing fields such as author, hash, timestamp, signer, receiver, etc. Right? So this is how we define them. And then the second step, you may recall, is the manifest file, which is the project.ts file. And this is the configuration. So if I scroll down, see that I've got the endpoint that I chose by default. So this is where I'm going to get the data from. I've also got a start block as well. So if this is 1, it'll be the Genesis block. At the moment, we've selected about 80 million for this particular example here, and this will change shortly as well. And then the last file is the mappings file, which is in the sources directory, mapping handler. And this is where a lot of the coding takes place, right? Okay, so you can see that the dependencies have loaded, which is good. Now, the next step, what I want to do is if I jump back into the documentation, this quick start guide here, number one, I want to update my schema file, right? So what I'm going to do is copy this out here. We've got 2 entities. One is the Oracle entity, where we're indexing the creator, the block height, the timestamp, and also the price as well. So let me copy this out and paste it in our schema file. So I'll just replace, select all, delete, and paste this in and save it. And what this means is that you'll see we've got asset ID, which is of type string. We've got price of type integer. The exclamation mark means that it's mandatory. What's also interesting is that I've got this field here called Oracle that is of type Oracle, which is this object up above. So we can actually have this kind of one-to-many relationship, so to speak, where a field can be of type of another entity that we've defined as well. And again, this relates directly to database tables and how databases can link or reference other tables too. So this is the schema. And of course, when you're designing for your own project, you could design this and specify the type of data that you want to grab. After this, let me scroll down. We want to update our manifest file, right? So I'm going to change the data sources section because I want to copy this here. And what this is saying is that we want to index from block 84 million. And we've got some filters that what we're saying is that when this filter criteria trigger this function or this handler, right? So when we find an add Oracle method name on the near blockchain, handle new Oracle. And for the second handler, when there's a report prices method, we want to call the handle new price handler. So let me copy this like so. Jump into my project manifest file here. On parameters above, we don't need to change much. Usually, it's just the data sources section. Just a step. I'm going to go ahead and update my map. Just copy this across. So I copy this, go to my mapping handler, select all. I'm just going to do a bunch of functions and types as well. And then I've defined two objects up above, new Oracle and new prices. But the interesting part comes down in my functions, right? I've got my handle new Oracle function. And if I put this to one side, you'll see that the handle Oracle function name corresponds to my handle new Oracle handler, right? So once this filter criteria is met, it will trigger this handler, which will trigger this function. And this function, what it does is it logs some information to the console, and then it'll go ahead and actually call this helper function down here. The second function, very similar, it logs some information out, calls a helper function, and then it goes ahead and actually gets the data from the blockchain and assigns it to our fields. Right. That's pretty much it. Let me save this, and now I'll first of all, and then I'll go and build the code by running yarn build. And the last one is to start Docker, which is basically the command yarn start Docker, like so. However, if I go ahead into my package.json file, I've also got a shortcut where I can actually run yarn dev, which will actually run the three commands in one go. So it'll run code gen, build, and then Docker compose and Docker up as well. So yarn dev is the quicker option, like so. Now what's happening in the background now is that it's going to pull down some images from Docker. You can see here, I've got 3 images, Postgres database, the GraphQL engine, and also the Subquery node. So this should go green one by one. So 2 out of 3. And once this finishes loading, what I'm going to do in the meantime is let's go into our documentation and I'll grab out a sample query. So just scrolling down here. Here is a sample GraphQL query that I can use. Let's copy this out. And I want to go to localhost. Let's go 3000, which is the playground here. And let's go paste, hit run. And you can see I don't have any data at the moment, right? But it's indexing in the background frantically. Hit run. Give it maybe another 10, 20 seconds. And there we go. Oh, it worked. So this is actually live data coming right now from the blockchain. We're grabbing the first 50 only. So you can see it's changing here, the ID, etc. Now you might be asking, how can I cross-check this, right? Well, one thing we can do is we can go to a near blockchain explorer. Right, so let me go to say nearblocks.io, just an example here. And I can go ahead and grab this ID here. Let's paste it in here. We'll do a quick cross check. Let's go and let's go into the execution plan here. And it's actually the actions area here that we're looking for. So I'm looking for a price of 9,999. In here. Oh, here we go. So 9,996, and you can see there's 22 decimals, 22, 22. The asset ID is USN. So there's a match, and this is also coming from pythia.near. So that's the ID. The Oracle ID here is pythia.near as well. So there we go. Just a very quick example of how you can get your near project, the Oracle, using a doc to the slides here. Just a screenshot of what we saw before. The data matches what we saw on the Block Explorer, which is good to see. And again, this is a kind of project where it's supposed to help you get started to create your own project very quickly. Let's just go through a quick sum here. We looked at what is query and why you'd want to use subqueries, the benefits. We looked at to create a project, basically the three files that we saw, the schema file, the manifest file, and the mappings file as well. And then you saw a quick real-time example of indexing all the price submissions from priceoracle.near on near mainnet. And it was pretty cool how it was indexing fairly quickly. Just a quick note on the subquery network, the decentralization and tokenization of the network is the next big step for subquery here, where you can completely decentralize your application stack and incentivize your community to help run your infrastructure as well. So if you do want more information, you can scan the QR code there. Otherwise, if you want more information, feel free to reach out on our documentation page, or some of the links here as well. Feel free to contact me on LinkedIn. Also, jump into our friendly Discord community. People are always willing to help there. So with that, that's it. Let's open up the lines for any questions. Hope that was useful. Hope that you got a quick insight, a quick taste into how you can index very quickly data on the near blockchain.
So can you kind of go into like the decentralized subquery network? How does that work? Like, do I still gotta run my own like Postgres database and like Docker, or like how is that offloaded to the community?
Yeah, good question. Give me a second. So the way it works is if I go to just move this out. So the network is called Kepler at the moment. It's basically a pre-mainnet. I mean, it's live on mainnet, and the URL is Kepler here. And what happens, paste it in the chat, is that uh, there are indexers on the network. They have their own infrastructure. So if you want to become an indexer and earn revenue, you can do so if you've got your own infrastructure. Otherwise, for your project, you can then provide it to an indexer who will run it for you. And then you use the KSQT token to pay to consume the data. So in that case, you'll be a consumer uh, purchasing from an indexer. And then there's also a third participant called a delegator, where you can, if you've got tokens, you can stake or delegate your tokens to an indexer. Basically, you would then get a share of the rewards. So whatever the indexer earns from the consumer for selling data, they share that with the people that have staked for to them.
So does it just look like a GraphQL like call, or what's it look like for like how does
Ah, yeah, okay, cool, yes. So what happens is exactly, it's an API, a GraphQL API call. And let me go to an example here. We've got Explorer. So for example, if I jump into, I don't think we've got any near ones. Um, let me go to, here we go. This is on our managed service as an example. I don't know if I've got anything on near. Oh, near dictionary. I've got this one here. Um, yeah, basically it'll be, you'd query this to a particular endpoint. Don't think I've got, this might be the endpoint here actually, the API subquery network endpoint. So you send a GraphQL query such as this to this endpoint, and then you get some data returned.
how do you facilitate the payment on from this
On the network. So the payment on the network here would be where, let's go ahead and as a consumer, first of all, you have to go ahead and grab um, some SQT tokens, and then you connect your MetaMask account. And then inside here, you can go ahead and set up a contract to a particular indexer in order to facilitate payments.
and then it gives you like an API key.
Correct. Yeah, you get a connection based on the contract, whatever pricing they set, you can then go ahead and agree whatever the price is, and then they'll give you access via API key.
Awesome. Given the current solution, like what is like how much does all this usually take to set up for like let's say like a kind of a smaller application? You have like any estimated costs associated with that?
In terms of a local project or one of the decentralized network or
A
managed
local
services,
project. Just the local projects.
a
Like if
local project on your lap, yeah, a local project on your laptop is just free to use. So yeah, there's no cost involved in setting up a local project. So I think you lost you there, shot. You still there?
yeah. So like
Yeah.
if I'm hosting it, like how much does it usually cost? Like what's
Also, if you're hosting it, so you develop it on your laptop, right, to make sure the project works. If then you want to host it, then it would really depend on your hosting provider. You know, you might spin it up in Google Cloud, you might spin it up on AWS. Let me just double check. For managed services, I think there's a yeah. So this is our managed service, right? Our pricing, where it's like there's a free plan, and then this is about 25 cents, 25 cents USD per app deployment hour. So as an indication, it's typically you're allocated some I think 2 CPUs, 4 gigs of RAM, and 20 gigs of hard drive, something like that, right? I mean, it depends on your project needs, but that's an indication there.
Okay, awesome. What if like you're querying something like NFTs and they have like separate metadata? How do you like usually handle that?
If you're querying NFTs for separate metadata, uh, if you're creating a project, then you could design it so that you're grabbing the data from different places and bringing it all, aggregate it, bring it together. Is that what you're talking about as a developer or as a consumer?
Yeah.
Yeah, so as a developer, you go ahead and aggregate it in your mappings file. So you'd point to, you know, if it's on just on one blockchain such as Near, you can grab the data there. You can then aggregate it. If it's across different chains or different ecosystems, you could then also, you know, query different chains and also aggregate it together in the mappings file. You know, provide a roll up if you wanted to, etc. And then you could present it in your front end GraphQL API.
Well, that's all the questions I had. Does anyone else have any questions in the audience?
Yeah, some pretty good questions there.
Like
Feel free.
I could build an API service on top of this. Is that what people are
Yes.
or like what are people commonly doing right now? Or, like across different networks in general? Are they using it for like NFT marketplaces, DeFi applications, like their own APIs or
Yeah, yeah. So the first question is that you could build an API on top because basically the data is in a database, right? And there's a GraphQL API provided out of the box, but you could build your own one on top of that. That's the first question. The second question is some of the common use cases, right? So what we've found is that people are using it to create or power their wallet projects, you know, their wallet DApp, power dashboard analytics as well, because you're basically just querying data from the blockchain that you can aggregate it and then serve it up to a front end and display interesting statistics, wallet data. You know, NFT is a popular one as well. You know, NFT transfers, the top 10 largest NFT um, tokens or wallet providers, etc. All sorts of stuff.
do you see any kind of like cross-chain stuff going on or like ex or things like
Yeah, yeah, we do actually, and it's becoming more popular as well, which is why one of the focus is just like a lot of other people as well, trying to grab data across different chains, across different ecosystems. And one of the advantages is that you know, you can do it all within one project, right? You just have to have different configuration files or manifest files, so you can point to the different chains, so the project knows where to get the data from and you know, what data you want from the chains, but it all comes into one project, one central place, into one database table, so to speak, depending on how you architect it. And then you can aggregate it all in the mappings file as well. So it becomes really handy and convenient in having this central place where you can get the data you need from different sources.
is are there any other questions or
probably asked them all for everyone, which is awesome.
Yeah, if not, it was awesome. It was very clear and concise. I captured all the links. We'll put that in the description of the video shortly. But yeah, thank you so much for coming out.
Uh, quick, if I may. I
Yes.
don't know. Okay. Since you are here, I don't know if it pertains to this, but you might be very helpful with this. I've shared. We're currently building a project. Okay, let me just send the problem in the chat, and if you have any solution to it, that will be helpful.
Sure thing.
Okay. Sorry, give me a minute.
No problems. While you're doing that,
So I just shared. We currently building this project that lets you characterize your near to access Web2 credit. But however, we have a problem with Droplet. The APIs they are working, but to connect to the droplets on DigitalOcean, it's giving so many problems. But I've detailed it down in the chat. If we can just take a minute to read through. If you have any solution or you think should be done.
got it. Yeah, this is probably quite a technical question involving the infrastructure within DigitalOcean. It looks like you've got a
Yeah.
Docker container with an external database that you're talking to on port 3000. All the tests with the external database works locally. Yep, that's fine. The current issue is the Docker IP refuses to connect when we try to ping an API server to check if it's a firewall issue. Yeah, so what's interesting here is that because you're using DigitalOcean, which is you're using their infrastructure, depending on what access or permissions you have, you might need them to help test and make sure the firewalls are open to trace what the issue is, because it seems like you can't access it through a particular port or an IP. Have you tried asking DigitalOcean?
Yes, we tried sent a few messages, but the customer service is really not giving what we need. Very unresponsive at this very point in time. That's why I'm trying to ask.
I'm gonna end the
Yeah.
recording real quick because this is a related question. But